for joining us this morning. My name is Ashanti Mbanga. I am the project manager for energy and environment at SANEDI. I'm specifically looking after energy efficiency, appliance standards, and labeling. SANEDI is a government agency. We report directly to the Department of Mineral Resources and Energy, and we established by the Energy Act of South Africa, which accommodates for us to undergo energy-related research and to promote energy efficiency across the country, to boost the economy, to gain energy savings, and to ensure that we reduce the associated greenhouse gas emissions. That's just by way of introduction of myself and the company that I represent. I'm joined by Bjorn, who I will introduce shortly. As our lead trainer for this session. And of course, just a warm welcome to you all from me at SANEDI and the SAEE team, which is assisting us, that is the South African Energy Efficiency Confederation. They are our co-hosts for this training session. So we are very glad to have you all with us this morning. I do want to also just extend appreciation to you all, perhaps also to give you the opportunity to make yourselves known within the chat box. So if you do have access to your chat box, just type in your name, the organization you're from. I think it's always exciting to meet new delegates that happen to be in the same space as us. Perhaps some of you are from academia, the industry, or government entities. Perhaps you're just a member of the public with an interest in energy efficient lighting. So it's just a great opportunity to drop your name, the organization you represent, and perhaps you might make a connection that will be beneficial to you. I'm going to go through a couple of house rules. Just ask that everybody please keep muted. We will have an opportunity during the session where you will be able to pose your questions to us. So that will be facilitated a bit later, but allow us to just go through the formal training presentation before we do open up for the floor. I'll also ask you to please keep your cameras off, just so that we can extend the bandwidth and have our attention on our presenter for the day. Then we'll also have a short break, sort of midway through the presentation, possibly around 12 or just before that. I will flag when we are about to take our break. So if you can just bear with us. The training has been extended by an hour. So some of you may have originally seen a poster for 10 to 12, but today's training will actually be from 10 to 1, just to accommodate a short break, but also so that we can allow the opportunity for any questions that any of you may have for Bjorn, who will be the lead trainer for the session. I'm going to go into introducing him. I think in the lighting industry, he's a man who needs very little introduction. We've worked with Bjorn for quite a long time in the space, and I must say it's a pleasure to have somebody who's really breathing and living energy efficiency lighting. He's very passionate. I recall even as we were preparing for this training session, he requested that we make the presentation template have a darker template. And so I was like, why would we do that? Because we have a standard template which has a white background. And he said, well, if the screen is darker, it's saving light on the side of the end user. And I thought that was just so phenomenal. And so I shared it with my line manager. And now we're actually considering having a darker template for the company. You know, it's the simple things. And I think that speaks to energy efficiency. They're low-hanging fruit and they are complex solutions to what we do. And today's training is going to cover a spectrum of sustainability opportunities within the lighting space and in different areas. Lighting is so crucial to our everyday lives. It's in our buildings. It's key for certain sectors and operations that take place within industry. And so we don't take it for granted. There's also the fact that some people still don't have access to lighting. So it's crucial that we do supply lighting and use lighting in an environmentally sound manner as well. to try and gain efficiencies and to save emissions. So I'll go into introducing Bjorn, if you will allow me to just go through his bio. He's a consultant who is EXA registered. He's a professional engineer and lighting specialist with more than 17 years experience. He studied electrical engineering at the University of Pretoria and obtained his undergrad degree in 2005 rather, and his honors in electrical engineering in 2009. He has been a lead technical advisor on energy efficiency lighting and installations for the implementation of lighting technology and infrastructure in the South African sector as part of the rollout of energy efficiency programs. And he's developed draft minimum energy performance standards. This is a tool that we use in South Africa, just making sure that we are not importing subpar technologies for the South African market. We refer to them as MEPs, and he's been instrumental in developing MEPs for street lighting and flood lighting luminaires for South Africa through a collaboration we have with CLASP and our work that we do here at SANEDI on the directive of the Department of Mineral Resources and Energy. And he's currently appointed as a lighting advisor, as a technical lighting advisor for the Department of Employment and Labor, reviewing the environmental regulations for workplaces. Bjorn also embodies passion for lighting, as I had mentioned in the opening of his introduction, for lighting and electrical energy and efficiency, and has turned his passion into a successful career. He values quality engineering and services that are of benefit to the public and their well-being and safety. So I'd like to introduce Bjorn to the floor. Bjorn, thank you so much for being with us. Over to you, and wish our participants an enjoyable training session.
Thank you very much, Ashanti, and thank you very much for that wonderful introduction. It's grateful to basically have this privilege of giving this training session to everyone and to basically share the knowledge that I have available. And I do hope that everyone here can basically take something away from it. So just give me a moment just to quickly bring up the presentation and take it from there. Just let me know if you can see the presentation slide.
Visible. Thank you, Bjorn.
Well, thank you very much. I must just gotta just put up my video just to also save in terms of bandwidth from my side. And so yeah, we are pretty much here today basically to discuss energy efficiency around lighting. And part of the agenda today is what we're going to be looking at are 10 topics: defining quality energy efficient lighting, sustainable lighting, trends in South Africa, how lighting should be regulated, what is quality and efficiency in terms of lighting, how we should basically go about procuring lighting, the importance of maintenance, and then some examples of applied lighting and the efficiencies that one can draw from applied lighting, and then just looking at various, looking at light in a different way from our everyday norms, and then demystifying labels and packaging. So the poll should basically pop up now, which ultimately is just going to just ask everyone what technical knowledge or background or understanding each of you may have in terms of lighting. So I'm just going to just pause there for a moment. So I need some eyes on there if the poll is coming through.
Yes, we've received it. Thank you.
Okay, cool. One moment. Just need to familiarize, just get this through. Okay, and we'll just give it a moment just to basically just let everyone poll, and ultimately then we can just get the results in. Okay, question one. Okay, cool. Okay, so we've got 17 people, 19, 20. Get in there. It's good to see that basically lighting is very important to everyone. Okay. Cool, I'll keep it there. All right, thanks everyone. Let's see it rolling in. Awesome stuff. Okay, so basically we can just close that then. Results. All right, so are we back to, can anyone basically see the presentation now? See that the question was a bit different. As we go into defining quality energy efficient lighting. Can we all see the presentation?
Yes, Bjorn, can I just pause you for a second? I just want us to get clear instructions on how you want us to participate on the poll. I do see some participants are commenting on the chat, commenting their responses on the chat. But is there a button that we press on the screen? Because I did see a pop-up that came after the slide with the question. So can you inform us which method you prefer?
Basically, there should be a pop-up.
Okay.
Sorry.
Okay.
Question. I can confirm everybody did complete the poll.
Okay.
Okay, so we should use the pop-up and not the chat for the poll responses.
Please. All right, so currently now I've got the, sorry, first I'm using the poll on this. And the question related is basically should have popped up now on screen. If all of you can just take a moment just to basically go to the poll and just answer the requested poll that's there, which relates to what is your understanding of lighting. Do you know how is the limit to just to flicking a light switch, changing a light bulb, being able to install or maintain the lighting, or basically design lighting systems and smart lighting control? I hope that poll is basically visible.
Yes, thank you, Bjorn. I think we do have all the responses. We just wanted to confirm the uniform way of responding.
Sorry.
Yeah, thank you so much. You can continue.
Want to continue. Okay, sorry, I'm just going to just redo this poll here quickly. Apologies. All right, so this one should be open now for everyone to then, yeah, there we go. Now it's working. Yeah. Wonderful technologies. Apologies. Okay, so we just give that a moment, just give it a minute overall, unless everyone finishes before then. Okay. That's a good mix. And basically, with this mix, I'm definitely hoping that I can shed some light on energy efficient lighting. Okay, so that's the minute up. I'll basically leave it as such and end the poll for that section for question one of your understanding of lighting. Okay, and now I'll share that result. Okay. And then that should be done. Okay. Shanti, can you just confirm if that all worked out well on your side?
Yes, it did. Thank you. I have the result on my side. 82% participated, and we've got a fair share of the response percentages also reflected there. Thank you.
Awesome stuff. Thank you very much. Okay, I thought it'd just be very interesting that we can then just see what how we're going through it. Okay, so in defining quality and energy efficient lighting, we need to basically just find my mouse. Understand that to us, light is life. All right, so much so that without light, we personally won't grow, plants won't grow. I mean, if you think about it, the natural light that basically comes from our nearest star, ultimately heats and plays an important role in precipitation, bioorganics in terms of the soils, wind, and all of these elements that we experience, the climate, and what we take for granted on an everyday basis, just being able to breathe. I mean, light has a very important impact to our existence on Earth. So first and foremost, from my perception, light is life. All right. With that, we move on to what constitutes lighting. In its scientific form, basically, it's electromagnetic radiation, which is basically able to produce a visual sensation within the eye. And this really stimulates a sense of sight. And if you do look at the electromagnetic spectrum, I mean, out of the entire vast array from radio waves through to gamma rays, there's a very small band which our eyes are only able to basically perceive, and which gives us the perception of everything that we see around us. To that, there is a large spectrum beyond our visual sight that leads to non-visual cues that also impact us, and that really stems to human-centric lighting, where we look at how light influences us physically as well, or visually, as well as non-visually. In terms of how we measure light scientifically, we look at the intensity of light, and that really just describes how much light, or luminous intensity, which is the SI unit of candelas, and that basically describes the measure of light being emitted from a light source, basically in a specific direction. So if you were to take an ice cream cone and stick it into an ice cream ball, that pretty much is the amount of luminous intensity coming out from the center of the ice cream ball, just to give it a different perspective. And when you look at the overall light being emitted from a light source, that is referred to as the luminous flux. And so when you look at the lamp packaging, and it says 650 lumens for a 7-watt LED lamp, that 650 lumens is referring to the overall luminous flux, or the overall light output from this lamp. Okay. And then how do we go about measuring the amount of light that is emitted from a light source, so that we can get a gauge if the lighting is adequate on a surface, or basically as perceived from our eyes? And we measure this through by measuring illuminance with the SI unit of lux. And this refers to the amount of incident light that basically illuminates a surface. So we are looking at the, so I'll just get a laser pointer. We're getting the luminous flux, which is basically being emitted from the light source, which falls on a specific area, and that ultimately refers to lumens per square meter. Okay, and then the measure of what is the amount of light that is reflected off a said surface to the observer. And this is the measure of light that is emitted from the object surface, or an object, in a specific direction. So we're looking at that specific area over a specific distance to basically the observer's point of view. So in the picture below, you've got the sun sitting in the background, and you have a silhouette of a man. You only see the silhouette of a man because on the non-lit side, the side that we are looking at, there's no light being reflected from his backside, and so hence we get a silhouette. Yet if you look at the surface ground that he is standing on, there's a lot of reflection off the surface, and that is what we are basically seeing in terms of the light in the sky being reflected off the ground surface. And then from there, understanding the amount of light that has been emitted from a light source and how much energy is being consumed to basically emit the amount of light in terms of watts, we are able to determine the efficiency or the efficacy of the light source. So we end up basically with initial oil lamps, which produce about 0.1 lumens per watt, moving on to incandescent light bulbs or lamps of 16 lumens per watt, where a majority of the light source is basically dissipated as heat rather than actual light. Fluorescent technology of 100 lumens per watt, and then LEDs at chip level at about 200 lumens per watt. So indicative of it being rather energy efficient. And so this is pretty much the progression of technology in terms of lighting. Okay, so then what then is quality energy efficient lighting? It is about being aware of your lit environment. I mean, understand how lighting impacts around you as you basically wake up in the morning, have your breakfast, get in the car, go to the office or to the site. Do you open up your laptop, look on your phone, and then basically travel back? Do you travel back in the early mornings, late evenings, where you basically rely on your vehicle's headlights, public lighting, and then ultimately your activities during the night also? And then ultimately, how can you better utilize natural light as well as artificial light, turning off light switches when not in use, using energy efficient lighting products, dimming and controlling lights. So basically it's about providing good energy efficient light without compromising the quality of lighting and lighting levels. So that's very important, in that you don't want to basically revert back to say candle light to undertake high maintenance or high inspection tasks. Rather have the quality lighting using energy efficient technology. Okay, and so now that basically brings us to the end of the first section. Are there any questions while we basically get the second poll going? Okay, so that was that one which you already had.
Just when we're discussing lighting today, and when you're talking about lighting, are we going to discuss it in a passive and active sense, or let me say, passive sources versus active sources, if you can put it that way?
Okay, sorry, just elaborate in terms of your passive and active sources.
So I suppose I'm thinking from a design point of view and from a source point of view, I would consider electrical lighting to be an active source of lighting, and then consider natural light to be a passive source of lighting. The one you're actively using energy to generate the lighting, and the other we're using what's available in nature.
Agreed. Okay. It's not normally a reference under the lighting scenario, but a valid point that you make in terms of the energy perspective, in that it's active in terms of consuming energy, whereas you are reverting back to natural sources, which is more of a passive element. I mean, in addition to natural or passive lighting, is another example is natural shading versus artificial shading. I make and that's really yeah, something to take note of, because ultimately, if you think of it, is that if you plant trees in the southern hemisphere on the north facing side, ultimately those trees, and they are perennial or seasonal trees, providing shading and cooling, as well as reducing excess sunlight entry into said room. All right, so that is a passive control. It's beyond our element, rather than using electrical control for that. And then, of course, the reverse happens in winter, whereby the sun is then basically used to heat the room and provide that additional light in the winter months.
Cool. No, thanks. I just realized it's actually a lighting standard presentation. So I'm looking more at active sources, not a necessarily design type of discussion, because that would be more on the green building side, I guess.
Yeah. All right. So just quickly going through if there are any questions. Okay. 1 minute. Okay, and we have basically probably one of maybe SIs. Okay, thanks. Okay, that's presentations. Okay, sorry, I'm just quickly going through if there's anything to slides. Can you elaborate, or is it still coming? Yes. So with regards to glare, that is a topic that is still coming up. So we're happy to chat about that a bit later. Okay, in terms of the polls, we are sitting at 43, so we can close that poll. Happy with that. Okay, and then of course, good to know that everyone basically appreciates good lighting. Okay. Thanks very much. And then labeling. Okay, so in terms of energy efficient labeling, that will basically come out a bit later down in the presentation. All right. So moving on then. So thanks very much for the answering the polls and questions. Moving on to sustainable lighting. Just getting my controls coming around. Yeah. Okay, there we go. So, sustainable lighting. And why is this going? Sorry. Okay. Apologies, everyone. Just want to just follow up. Sustainable lighting presentation is visible, correct?
Yes, thank you, Bjorn.
Thank you, Ashanti. Okay, so what are sustainable development goals? Sustainable development goals are the blueprint adopted by the United Nations to achieve a better and more sustainable future for all by ending poverty and to assist in protecting the planet. So basically reducing greenhouse gases and securing resources. And there are 17 sustainable development goals, ultimately as which can basically be presented in this video. I'll basically share with you now. All right. Okay. So how does lighting contribute to the Sustainable Development Goals? Firstly, let's have a look at providing no poverty. Ultimately, by having lighting, giving access to persons who do not have electricity or who do not have lighting, that basically assists in bringing them up from a poverty element. And if you look at zero hunger, ultimately vertical greenhouses or basically artificial lighting to promote growth of various foods, they can really contribute to zero hunger, good health and well-being, while good lighting in hospitals basically improve recovery times. And then we are very much dependent on lighting in terms of human-centric lighting. So good quality lighting improves our mood and well-being. Quality education, again, through having quality lighting or access to lighting, those that do not have these services would basically be able to improve their educational status, being able to basically do their homework, be able to read when they do not have luxuries of that first world countries have. And then clean water and sanitation. UV lighting can basically be used in the clean water sanitation and filtering systems. And so then moving on to that, affordable and clean energy efficient lighting technologies being used wisely, reducing energy demand, and then of course decent work and economic growth. While basically providing good quality lighting, you improve the performance of employees and therefore performance of the work output, and as such basically economic growth and decent working environments. And that ultimately promotes industry growth and innovation as well as infrastructural development. So in that, with the infrastructural development and innovations, these lead to reduced inequalities from impoverished communities to middle class and to upper class, giving equal access to education, food and well-being, as well as energy and economic growth and prosperity and opportunities, which then ultimately leads to sustainable cities and communities, which therefore improves climate action in reducing greenhouse gases and using renewable or recyclable materials, and using energy wisely and lighting for all. And that pretty much promotes life on land, whereby basically you do not use, I would say, just as an example, 6,000 Kelvin, which is basically daylight lighting at your beach fronts, as this greatly impacts on your aquatic life, and similarly goes to land life on land, where birds and bats and insects are also affected. So looking at environmentally sensitive lighting to basically promote ecologies and life on land. So lighting is definitely a means of providing access to sustainable and energy efficient lighting solutions that would be a benefit to all. Any questions in terms of sustainability? Let's go to the chat.
Not quite on sustainability, Bjorn, but I've just noted two questions in the chat, maybe while you bring the poll up, from Dr. Tlabela wanting to know if they're wanting to know more about glare. And are you going to elaborate on this? Is it still coming in your presentation? Just also don't be afraid to mention if it's out of scope for today.
I will be touching on it in terms of lighting quality and efficiency in the next in section 5.
Okay, fantastic. And then just one more from the chat, maybe before you open to the floor, from Tabiso, asking if you're going to touch on energy efficiency labeling, in particular related to the new regulations.
In relation to the new regulations,
Yeah.
that's an interesting one. In terms of labeling, yes, I will be touching on it. In terms of the new regulations, just quickly
Perhaps
delve
I can take that part.
Sure.
It is our responsibility. I'm happy to elaborate on that, but perhaps after you cover the section around the general energy efficiency labeling. Yeah.
Awesome stuff. Thank you very much,
Okay.
Shanti.
Thanks,
Okay.
John.
Awesome stuff. Right, so we have basically got 44, 42. I'll just give it about 30 seconds more, and then I'll close the poll for how accessible is lighting to you at night, whether it's at your fingertips, whether you need to use your phone or other forms of lighting, whether you depend on external lighting or that you have no access to lighting. Okay, and I'm closing the poll now. So very interesting. Majority of us here today have lighting at our fingertips, where others are basically dependent. Good 30% of us are dependent on other forms of lighting, whether it be through external lighting, area lighting, street lighting, phones, or torches. So very interesting to note. Okay. And moving on then, light trending in South Africa. So what is basically happening? Sorry, what is happening in South Africa? From a consumer side, consumers are becoming more environmentally conscious, and with that is a growing demand for energy saving solutions. And that's really one of the driving factors is load shedding, and looking at lighting technologies with either built-in batteries, solar lighting, and then ultimately the rising costs of energy. And of course, in addition to that, if people are implementing or going out and buying generators or solar systems for their homes, they are then becoming more conscious of how much energy they can actually be loaded onto their own supply system. And so they need to look for more energy efficient technologies or solutions. And then, of course, there's a growing awareness towards human-centric lighting, how it basically affects us in healing, in hospitals, in schools, in ability to learn, and basically improving the working environment, as well as just our overall well-being and our connectedness to natural light, and how we try and focus on mimicking natural light to improve our human-centric synchronicity, basically. And then, of course, with that, consumers of liking apps and technology would like lighting to be a lot smarter, being able to operate from their phones, which LED products are more than willing to be adaptable for that, and also shifting more away from incandescent and fluorescent lighting. But with that, there's the negative in that the transition to efficient lighting is slow. Even though the prices of efficient technologies are dropping, it is still hampered by the buying power of the consumer and the murky product information. Okay, in terms of the industry, we do have a very large presence in South Africa, and it is growing, maybe not in terms of overall manufacturing, but more in terms of assembly and importation of lighting products. We have energy efficiency regulations, which for general service labs has been gazetted and issued, and so the local industry is needing to basically now comply to those regulations. There is LED dominance in South Africa in terms of importation as well as exportation of LED technology, adoption of smart lighting, integration of IoT in lighting devices, and we are moving towards compact and aesthetic designs and innovative lighting solutions and sources, growth in demand for outdoor lighting and automation, improved environmental and waste management of lighting products, where basically the manufacturers and industry are then responsible entities for their specific products in terms of end-of-life waste management, and then increase in importation versus local manufacturing, as I've already mentioned. So overall trends, as mentioned, is that there's a compulsory minimum energy efficiency and safety standards for light bulbs being sold in South Africa, solar lighting growth, making use of any existing lighting technology stock for maintenance before using new energy efficient lights. So from a maintenance perspective, it's a first in, first out approach. I have incandescent lamps. Why must I get rid of them now? First, let me use them before purchasing LED, more energy efficient lighting technology, or otherwise fluorescent tubes. And then, of course, procurement based on energy savings and slow moving towards lighting compliance, where that basically relates to the focus of how much energy can I save, how much financial saving can I get if I reduce consumption from 100 watts to 20 watts, or can I reduce it even more? And the side comment from my side there is that we need to basically look at energy efficiency in relation to providing quality lighting, because if you are only looking at the energy side of lighting, the most efficient solution is basically no lighting at all, or basically just making use of natural day lighting. And then, of course, lighting product performance and quality does vary at the moment in the country, as there have been various case studies basically showing a lot of variance. But with the regulations, there hopes to be a normalization in terms of quality and performance, and information being given to the public. Okay, I'll assume that there won't be any questions in terms of trends in South Africa. So new energy efficient lighting solutions also have some other environmental implications. Waste disposal requirements may need to be taken into account. That's from Richard. Agreed. Very points. That's basically, yeah. That's definitely a more detailed discussion outside of this training for today. But I can definitely comment that we do, and it comes back to sustainable lighting technologies, that we need to basically look at how we can basically guard and protect the earth and its resources as we basically evolve with the technology, as we make it more efficient, not only efficient in terms of energy consumption and providing light, but efficient in terms of reuse and recyclability, or at the end of life. All right. Then moving on is basically, how do we go about regulating light? And as I've already covered, some reasons as to why we should have standards and regulation for lighting and lighting products is, firstly, safety and well-being, visual comfort, visual performance, and improving productivity and efficiency, not just of the products, but basically of employees in the working environment. And then, of course, economics. in terms of the manufacturing, design, disposal, and use of the lighting products. So some of the standards that are available in South Africa that can be that should be referenced when implementing lighting designs or referring to or looking to retrofit or replace existing lighting infrastructure is the environmental regulations for workplaces. And as I mentioned in my bio, I am participating on the technical committee there. And as what the initial draft came out last year, what's very interesting and which I find very of value is that it's not only the employees or the employers that are responsible for providing minimum lighting requirements, but also designers and manufacturers. So if a product doesn't perform and it is used correctly by the employer, manufacturers could basically be held liable. In the same, if a lighting design is not designed correctly, the designer may be held liable if it is implemented correctly by the employer. So it's very important that we do at least meet minimum lighting levels, and the basis for that is around safety and risk mitigation in the working environment. And then in addition to that, we have the SANS 10400 building regulations. Section Part O refers to lighting and ventilation, and Part T refers to fire protection, and the section of fire protection references emergency lighting requirements around fire escape routes under certain conditions for various building classes. And then section XA refers to energy usage in buildings. And moving on from there is basically SANS 1544 energy performance certificates for buildings. And that's ultimately evaluating the overall building use, of which lighting does impact in terms of heating and cooling, as that impacts on your ventilation systems, and then basically overall consumption from your lighting as well as control, which impact on your energy monitoring and verification, which contributes to your overall EPC certificate for the building being obtained. And then ultimately there's SANS 204, which relates to energy efficiency in buildings. And just to basically give you an example here, we have various classes of buildings ranging from entertainment and public assembly through to high-risk industrial, hospitals, large shops, offices, hotels, and dwellings. And ultimately, the amount of lighting that is considered per person or per area is given, and that is the watts per square meter that maximum demand in providing sufficient light for 2 people in a bed or a bedroom. And the overall consumption, for example, of a dwelling is 5 kilowatt hours per square meter per annum. And so taking this information, what does it actually mean to a homeowner or a hotel manager or maintenance staff? Okay, so how does 5 watts per square meter look like? Looking at a home dwelling, well, it's 25 5-watt LED lamps at 450 lumens installed in a 5 meter by 5 meter room, and that relates to basically 5 watts per square meter, giving you about 230 lux on this desk here in this specific room, and that's an overall consumption of 125 watts for a 25 square meter room. And from here, from a energy efficient perspective, understanding the table, how could you basically reduce the energy demand further from the 5 watt per square meter? Well, let's consider 2 30 watt 600 millimeter LED panels, which have a light output of 3,200 lumens. We put that in the same room dimensions, and then we basically end up with 2 light fittings rather than 25 light fittings. So it's much easier to maintain and has a connected load of 60 watts from 125 watts. So your overall energy demand is now reduced from 5 watts down to 2.4 watts per square meter, while still providing you equivalent or higher lighting levels. So we were at 230 lux, now we are at 260 lux on the task area. So that's where standardization or standards come in to assist us in developing, designing, and implementing more efficient lighting designs and good lighting. In addition to that, we have lighting standards in South Africa, which refer to SANS 10114 for interior lighting, emergency lighting, which is referenced by the Building Regulations Section T, exterior lighting and security lighting to improve external exterior workplaces, as well as improving security from a visual perspective. And then what is of importance is also to take note of light pollution and how to mitigate it. And then, of course, if you do travel...
German embassy, France, and all those guys would be top of the list because they're big, right? So,
Helen, kindly mute,
embassies.
please.
So what's going to happen?
The sound is coming from you.
The person who's going to look at the website site, okay?
Helen, can you mute your microphone? Okay, thank you.
Thank you, Shanti. Then we look at public lighting and roadways, and that basically gives guidance on the amount of light to have on our public roads, municipal and national roads, residential roads, to basically assist motorists and pedestrians moving around on these freeways, so that they can have visual perception on being able to navigate easier and safely identify objects that may enter roadways. For example, in residential areas or around schools, in addition to speed bumps, lighting basically would help motorists see children crossing before looking, and so avoid those sort of incidences. And then, of course, we have regulation of lighting products, as mentioned, is the gazetted minimum energy performance standard for general service lamps. We have VC 9109, which looks at the efficiency and performance of general service lamps, and then VC 9110 that looks at the safety of lamps. And so basically VC 9109, ultimately, how does the light fit the lamp perform? How much light does it give out at a specific minimum requirement? And then, can consumers handle and operate the lamp safely without being at risk? Okay. From localized regulation, we have regional regulation and policies for lighting. And here we look at harmonized standards of quality and energy efficiency in lighting products, which assists in promoting regional trade and opportunities. For example, the exportation of LED products from South Africa into neighboring states is a big benefit or opportunity around solar lighting, as we are basically inundated with solar lighting technologies, and then regional adaptation of standards, so, which makes it a lot easier. So if we are saying we have we require a product of providing efficiency or efficacy of 100 lumens per watt, our neighboring state will ultimately also have a similar standard, which basically makes cross-border trade a lot easier. And then, of course, we are also looking to protect ourselves as well as our neighboring states against product dumping, so we don't end up with a non-compliant lighting product, which may impact on the well-being of the general public. Yeah. Moving, any questions and queries? I see there's 2 in the chat. Okay. Are there regulations or standards around light pollution, the other side of the illumination requirements? I think, yes, there is 10389, which does give some recommendations or guidance around light pollution. Then there are multiple other standards internationally in that regard. Okay, I hope that answers that question. Any other questions before I move on to light quality and efficiency? Okay. Right. Okay. So moving on to light quality and efficiency then. Sorry, there's a chat. Good question that ultimately comes in. Well, does anyone police what lands on the shelves? All right.
That would
Okay.
be the NRCS, yes.
Right. So at this point in time, that would then only be specifically related to general service lamps. So that is, if I just quickly just go back there, VC 9109 and VC 9110, general service lamps, but there are other VCs that relate to other components of lighting. Ultimately, do go to the NRCS website under the technical guide, and then you can get a whole list for that. And really, that process involves a letter of agreement. If you are an importer or a seller or manufacturer, you basically submit your product to the NRCS to say, right, this is the product I'm intending to sell within South Africa. You get a letter of acceptance or approval from the NRCS, and then with that letter, you would then be allowed to basically sell the products on the shelves. The governing of that is then also done by the NRCS, and so with that, you also have the public sector, whereby if an individual such as yourself do see products that do not comply to the VC, if you are understanding what the VC compulsory standard is about, then you could actually make reports to the NRCS in that regard.
Hi, Bjorn. I see Jared has a follow-up comment to what you've shared. Yes, Gerard, the NRCS is still relevant to your point about going to physically check. They do what is called market surveillance, and they actually go in store. They do this for appliances and all regulated lamps under the NRCS to check whether what is actually in the retail stores is what has been declared by manufacturers. So there is a market surveillance function to that effect, and where there is or are illegal products that are found, there's confiscation and penalization that is part and parcel of that. So it's a full-on program that the national regulator runs. Thank you.
Cool. Thank you, Shanti. And then the next question for Nadifa: how are the OSH requirements factored within the standards? Basically, the OSH requirements, or basically I refer to them as, sorry, I just want to just get to that slide, the environmental regulations for workplaces. That is ultimately statutory requirements, or which stipulates the minimum lighting level requirements, that looks at minimum average light levels, or lux. The flicker or stroboscopic effect elimination, glare and uniformity, or the mitigation of glare and improvement of uniformity, in addition to the provision of emergency lighting under specific conditions, which relates ultimately to the building regulations. So first and foremost, environmental regulations is what you any entity or employer would need to comply to, and then from there look at the building standards. But ideally, these are the minimum. My recommendation to you is to basically look at referring to the actual standards themselves. Okay, and then, yeah. Any other questions before we move on then? Okay, no more further questions.
There is just one, Bjorn. Will you
Sorry.
take it? It says, what's your view on yellow and white lighting on street lights, especially when mixed in a single look E-road? I'm hoping that's not a typo, but you can unmute Dr. Tlabela and clarify if I haven't captured that correctly from your type-in.
Yeah, good morning. Actually, it's a typo there. It's on a single road. You find that there is yellow light, and all of a sudden maybe engineers or technicians replace a number of white lights. And then now the vision all of a sudden changes because of the mix there. And that also ties to my original question of glare. So is there no regulation to say, no, if you have got yellow light, it must be consistent, or if you have got white light, must be consistent on a particular road, road A or road B.
Thank you very much for your question. And it was a very interesting question, that one. There are mixed views, but from our perspective is that if you, for example, have yellow light and you start changing individual light fittings with the white light, I would not recommend that in terms of best design practice. As you're basically changing the lighting parameters, and ultimately a person's how can I put it, visual perspective needs to adapt and change constantly under those specific light changes. So if you have a section of road that is constantly yellow, your eye adapts to that lighting scene. Okay. And then if you then switch to the white light, your eye will basically transition to the scene of white light. So if you have large sections where you have changed over, which ties in with the maintenance programs of rolling out the energy efficient LED technology in replacing the yellow HPS lighting technology, because you can't unfortunately just do it all at once because of maintenance programming and budget and all that. So you have to do it part and parcel. But recommendation, do stretches to allow the motorist or public's eye to remain adapted to that specific lighting, rather than having individual lights change, because that creates variance in your lighting, and therefore variance in the eyes to strain on the eyes to adapt, and increases potential risk of not being able to and that's possibly where potential glare influences may come in, as well as potentially not being able to see other objects because the eyes become fatigued, and so on and so forth. I hope that's answered your question.
Yes, thank you very much. There's a lot, particularly where we're driving in urban areas where these mixes are. But I think it's because of the constraints of the budget and so on and so on. I wish there is a standard or a regulation to say, no, we cannot go on like this because of it may increase accidents, as you may say. Thank you very much for the answer.
Cool, thank you. There is a section in terms of maintenance where I go in a bit more detail on giving some guidance around maintenance strategies around lighting. Philip, thanks very much for joining. Appreciate it. Refer to maintained illuminance. This applies to the primary task area, which is internationally regarded as being between the secondary task area. Agreed. So that basically refers to areas and primary task area like this. Yeah.
Yeah, I believe that's a comment. There is a question, just one that's referring to Osh. Maybe we take that since you were covering regulations before we move to light quality and efficiency. Yes, are you considering the OSHA regs on all lighting? On lighting at all? Yeah.
When one conducts institutional accreditation of institutions, the ones that deal with compliance with all infrastructure rates, including lighting and noise in the line of OSHA records, how do these converge? Very good question. Ultimately, institutional code. Okay. Sorry, I just want to get clarity. Would you mind just give a bit more clarity on that one?
Okay, thank you very much, and thanks for the presentation. I'm asking this because if you as a person who has regulated private institutions, which is businesses that offer education, there's what we call institutional accreditation. As part of you have program accreditation and institutional accreditation for you to be registered as part of the registration, but that's an accreditation. As part of the institutional accreditation, the OSH Act auditors from Department of Labor were the ones that were dealing with that in conjunction with our guidelines as the regulator. But what they do, if you go to the OSH Act, it has specific regulations. It deals with noise, it deals with everything, the OSH Act. I'm not talking about the version that is within the mining sector. The mining sector has just reversioned it to fit the mining, and it has its own requirements. But the generic OSH Act, Occupational Health and Safety Act, has various regulations covering noise, covering the lighting, covering everything. And this has been what has been driving sanity within the infrastructure space. So my question is, how do we converge this side with what the OSH Act is requiring? Is there convergence within the auditors that we are using in terms of making sure that the lighting that is put is just not fitting the international standards, but is also complying with the requirements in terms of the OSH Act? And I'm asking this because most of the buildings you are using are buildings that end up being government buildings, and you have public servants that are there. So the marrying of these two becomes critical. Thank you.
That's a very interesting question. Well, thank you very much for clarifying that. Okay, I'll give my best attempt at this. So if okay, I'm going to do it. Try explain it through an example. Ultimately, consider a private company, a commercial company. They are wanting to build an office block. Okay, so in building this office block, they'll go to the engineers, say, right, we want specific lighting, ventilation, and so forth. The engineers will basically go to the design standards and design according to the standards to meet the prescribed requirements set in the standards. When ultimately the employer wants to occupy the said building, they would need to basically do a risk assessment in terms of the OSH Act to define any potential risks, and lighting ultimately is one of those elements that the employer would ultimately need to look at. In doing so, their risk assessment would say, okay, right, this is the type of task that we are defining to basically be undertaken in this part of the office. This is the lighting level that needs to be there. So the construction side of the building, the lighting level could basically be 100 lux. But in terms of the risk assessment that the employer must have at hand, they are saying, okay, we only need, because of this task, and referring to the OSH Act, we only need a lighting level of, say, 50 lux. So that's 50%. So they are well in compliance from the regulatory perspective, but they are also meeting the standard perspective in terms of the building regulations and lighting standards. So in essence, it comes in with good design practice. I myself would not refer to the regulatory perspective, because the thing is, lighting levels reduce with time. Okay, so if I design today at 50 lux, and that's the minimum requirement in terms of OSH, tomorrow that light could have depreciated. Now I'm sitting at 49 lux. That's an automatic failure. All right, so I'm already putting lives at risk. So from a design perspective, industry perspective, one should actually refer to the standards and then revert back to the OSH Act as a guidance to say, in terms of the employer and so forth, from a risk perspective, that look, you are now at a minimum requirement. You now need to relook at improving your lighting quality again. So that's really kind of like with the minimum energy performance standard for lamps. The OSH regulations is just from a safety perspective of, this is your minimum requirement that all entities need need to meet. And if it falls below that, you need to basically take remedial action immediately or within the prescribed time. And that's where the OSH auditors then come out doing these investigations, checking that the risk assessments are in line, that the specific risks are identified, and then doing their internal or audit of the various facilities and so forth, and seeing that they are in compliance with the regulations. Has that helped in clarifying or answering your question?
It does, though for me it's a problem that the risk is done after the effect, if you get what I'm saying. Because then the OSH auditors, like you're saying, they come from a regulatory perspective. At what point are we ensuring that innovators and legal people sit at design phase, not later downstream? Because that is where there's a problem between innovation, creativity, innovativeness, and I'm using these words carefully, and the human right perspective that is affected by all these products.
Thank you. And hopefully this sort of training or awareness basically makes those people aware, so, and brings that risk assessment to the forefront, so that when the employer sits down with someone who wants to, okay, let's look at something innovative. Does it comply firstly with the OSH Act? Yes or no? Okay, we need to re-innovate it basically, and then take it down the line, so the end result is something that complies to the OSH at the very least.
No, thank you very much. I just wanted to raise that because it is one of the troubles that are bedeviling innovation as we speak, whether it's drones, whether it's electric cars, but this not meeting of ICT lawyers and innovators is leading to debunking of human rights. And we need to deal with it.
Oh, thank you. Thank you. Very, very interesting questions posed.
Thanks, Bjorn. Should we move to light quality and efficiency, and then we'll have another Q&A session just before the break?
I will do that. Thank you very much. Okay, so
great, thanks.
Thank you, Shanti, and thank you for the questions, everyone. Light quality and efficiency. Lighting affects us visually, biologically, emotionally. All right, and the graphics basically demonstrate that quite well, and ultimately impacts our learning abilities, performance, circadian system, and well-being. And that's basically humocentric lighting. The humocentric lighting basically encapsulates how lighting affects us, and ultimately everything around us and how it connects us basically. And so it's very important that the quality of lighting is optimized to what it can be, rather than being a sideline project or sitting second fiddle to energy efficiency. So in terms of lighting quality, we look at visual and non-visual lighting, color accept appearance of light, color rendering, flicker and stroboscopic effects, and glare. So if you want to understand glare and stroboscopic and flicker, the information will be coming up shortly. So in terms of visual and non-visual lighting, one needs to understand how light may impact on your day, and ensuring good lighting design. And ultimately looking at the circle here at the very center is our well-being. And our well-being is influenced by visual systems and non-visual systems, short-term and long-term effects. So short-term effects are basically like flicker. If you're walking into the store, picking up a loaf of bread, and there's this light flickering above where you would collect your bread. Long-term effects is basically you're sitting in the office all day, like you would with ventilation. You've got the aircon at the back of your neck for the entire day. The same is with working at a laptop. You've got a light directly above you, and you've pretty much got a glare from the light fitting or light falling on your computer screen and basically being reflected from your computer screen and giving you discomfort glare, which basically ends up with you having a migraine at the end of the day. And so with that, you also get affected in terms of phase shift, sleeping disorders, melatonin suppression, alertness, pulpitary reflex, and then from a non-visual moving from a non-visual to a visual system, we have appearance, visual performance, retinal injuries, age-related macular degeneration, photobiological safety. So in terms of photobiological safety, we talk about UV and blue light. With non-visual systems, moving back to sleep disorders, if you have a very high intensity, say tablet or Kindle, or reading articles on your phone just before going to bed, that is going to disrupt your sleeping pattern. And then moving back in terms of retinal injuries, also we think of lighting as light fixtures, but any light sources. So for example, welding, arc welding, furnaces, all right, these generate elements of light. So high white light as you're welding, hence why we have personal protection equipment to shield our eyes so that they do not get arc eyes, for example, visual fatigue, and then ultimately vision. So how the light interacts with you as an individual, how intense it is, the spectrum of light, distribution, and the duration and the timing. So morning, natural light, nighttime, afternoon, and sunset. All of these basically have a vast impact on you as a being, and that's just light. Moving into the specific elements of lighting, so the color appearance of light. So as I said, the time of day, all right, changes the color temperature from a yellow, warm white color to a very blue daylight, 6,000 Kelvin light, and then moving back down basically to a warm, cool, sorry, I was about to say cool temperature, to a warm 2,000 low Kelvin temperature light again. Me personally, just to share some experience with you, looking at, this is a high color temperature, so basically blue, so noon, and that's a warm, so pretty much sunrise or sunset, and then basically various colors. So this is the smart lighting technology that is available, and so you can actually set your interior or artificial lighting to what suits your moods. And for me personally, I prefer standing under a tree in midday, all right, so that my eyes can adapt nicely and not be strained, because I don't like looking at the sun. And so personally, I have light fittings that are between 4,000 to 2,000 Kelvin, because that's what my eyes prefer specifically. And ultimately, this is also regional. If you go to the Europe, northern region, Scandinavian, they too also prefer the warmer whites, very low Kelvins of 2000, and then going to regions around the equator, you'll find that individuals or communities prefer the higher color temperature or the bluer light. So it is fascinating to see how lighting impacts us, not only in South Africa, but globally. Color rendering index, it's pretty much just refers to how does artificial light best represent a color such that when you take it out from that artificial light and you put it in the natural daylight, is the lighting comparable? And this is definitely used to its potency in terms of marketing. So in terms of clothing stores, you might find that there's like a green tinge in the light, and right below it are clothing garments that have green, so basically making the green product pop out more. The same basically goes in butcheries and bakeries, using warmer tones to basically promote the look of the meat, make it more appetizing to consumers. And then once you actually take it out, you actually see that it's actually blue rather than this nice juicy red steak that you thought you had. So those are the effects that artificial lighting can have, and how important it is to basically reflect it in the textile industry and overall consumer industry. Then, of course, the downside to lighting technology is flicker and stroboscopic effects. And these can definitely impede our safety and our well-being. I don't know how often I've had to look at this while doing presentations. By the end of the day, basically, I get aggravated and annoyed by it because of the constant flickering. And if you were to constantly look at it, your eyes do become fatigued because it's constantly irritating your eyes and may lead to migraines. And those that are photosensitive may trigger epilepsy. So this is even on public roads or in tunnels, where the strobing or zebra effect in tunnels or roadways are at a certain frequency when traveling, and may trigger epilepsy. And it's also very important in shopping malls and so forth. So if you do find this is flicker, stroboscopic effect is a lot faster and not generally seen by people. And really where stroboscopic effect comes in is that if you're working on a rotating machine, if you have a severe stroboscopic effect, that rotating machine, although on, can be seen to be stationary. And so if an employee does go to work on that rotating machine, then they may end up with a severe injury. And then, of course, if you do have sensory processing disorders, flicker and stroboscopic effect can basically subconsciously aggravate these disorders. Moving on to glare. I hope everyone was exposed enough by this flashing to understand the importance of mitigating flicker and stroboscopic effect. Moving on to glare, there are 4 types of glare: direct glare, reflected glare, like the example I used of light above an employee being reflected off the laptop screen. Direct glare would basically be from the laptop screen itself. Discomfort glare and disability glare. So in the picture over here, you can pretty much see that the person has become fatigued from glare. And if you look at their fellow employee, you can see this glow from this wonderful screen over here. And so that's direct glare onto this employee working on this screen. And in the background, you also see a glare, so you can't really see the details. So that's natural light glare. And with that, you don't use any lighting technology. You look at other lighting technologies such as blinds, curtains, glazed glass, to mitigate the type of glare from natural light, basically, or even artificial light. One of my recent concerns is all these digital advertising boards. Have a look specifically when there's load shedding and these digital advertising boards are on. They light up the entire freeway, and I can't see anything beyond them. All right, that is not discomfort glare, that is disability glare, in that I am unable, or I am what's it? Sorry, I want to say I just forgot the word. So it's not prematurely. Momentarily, my visual perception is impeded by this glare from these advertising boards. And if there is an object, a stationary vehicle in front of me, these advertising boards are such a danger that I could actually hit that vehicle because my vision has been momentarily impeded. So that's the seriousness of disability clear. And so with that is, how do you, I want to just pose a question here, is how do you picture setting off into the sunset or dashing off into the sunset? Do you view it as an heroic scene as described in novels, or being the more realistic, debilitating glare as you try to travel home safely? Okay, so moving on to from lighting quality to lighting efficiency, we look at energy efficiency and lighting control, and that really looks at how economical it is, or what savings can we do, how much do we need to spend, and how much can we save, and how sustainable is lighting efficiency. So how do we know, firstly, how do we know that the lighting we have is energy efficient? All right, does it mean that if we swap out the old watts, like 100 watt with a 50 watt, does it actually mean that our system is energy efficient? Well, let's start off by firstly assessing the existing energy usage of our existing lighting system. Propose a good lighting design that potentially will provide energy savings based on our baseline assessment of the existing lighting infrastructure, and then procure and implement energy efficient lighting and controls. All right, so with that, we have we understand what we have, and we propose something new to obtain energy savings, and then we procure lighting technology that is efficient and compliant to our needs and requirements. And then, of course, after implementation, most importantly, we need to conduct an audit. We need to measure and verify that what we have proposed and what we have procured does indeed give us savings in terms of energy while providing good lighting. So energy efficiency can basically needs to be provided through good lighting design and use of energy efficient lighting applications. So here is an office building. I want to bring your attention is that we have large open glazed windows that basically assist in lighting in this office. Then in addition to that, we have area lighting that lights the entire area with lighting control. And then if you want further lighting, this individual specifically needs a task lighting at their desk, so that in essence, if there is no natural light and the area lighting is off, they could operate normally with just a 5-watt lamp at their desk. So this is how you can maximize control and efficiency of lighting. And then with that, we need to understand the use of improved technologies in lighting. So looking at the incandescent all the way through to the LED, and the energy savings that we obtain, as well as reduced energy, electricity costs and consumption. Lighting control, looking at natural and artificial lighting, direct and indirect lighting, ambient lighting control, manual control, light switches, daylight or presence sensors, dimming and color control, and autonomy of lighting. And basically that kind of leads us to smart lighting and IoT devices. And with that, through smart lighting of systems, as an example in the lighting classroom, we can basically see how we can improve lighting conditions for learners, and therefore basically improve their focus and activation and learning in the classroom itself, just through the use of smart lighting and understanding the needs of the employer and of the work at hand, or in this case, the learners themselves, and ensuring their attention and focus during their time at school. All right, and to round off, basically, lighting quality and efficiency is just a general checklist that you can use to basically implement lighting to your needs. First and foremost is, what is the budget? I've had many clients say they want to do lighting. First question I ask them is, how much budget do you have available? And then I say to them, okay, right, well, you want this. Let me see what I can do, but please note that your lighting levels are not going to be compromised. If you are wanting these lighting requirements, your budget may need to be increased, because if you're reducing lighting levels or you're reducing the specifications, there are implications to that. So it's not a matter of always proposing the Mercedes-Benz or the Ferrari or the top of the line, but it's a matter of providing economical lighting solutions that provide good lighting with good lighting products that are energy efficient. Yeah. And so you need to understand what the lighting performance criteria are, as like the lobby to a restaurant. Understand the visual experience, the conditions of visitors, and activities being undertaken, and promoting the use of natural light. As you can basically see, the huge facade windows. And with that, you couple that up with the performance criteria of the lighting products to be implemented, and ensure that there is testing and certification and specifications behind the technology to be implemented. And the reason why we do this is because we want to ensure good lighting design, good lighting product, energy efficiency overall, and economic feasibility. Because you, as the employer or the end user, you want to ensure that what you've asked for is what you get. Here are two examples, basically festive Christmas lights, and then basically making use of the arch of a pedestrian bridge to safely light the way for pedestrians without creating light pollution and without unnecessarily lighting a unlit major road beneath it. Okay, and so basically bringing you to the end of section 5, lighting quality. And ultimately, I think, Ashanti, here's the time that we can just quickly go for a break. And in addition to basically, if there are any questions, we can ask them now, as well as the poll going out now.
Thank you so much, Bjorn. I do see the poll is up. I don't see anything in the chats. There aren't any hands raised either, but we're halfway through the training in terms of time and content, which I think is probably the perfect time for us to take a bit of a leg stretch. We'll make it a 15-minute break, 1-5, and if we can all be back at 11:45 sharp for the commencement of the second part of the training. Right, please do just try to respond to the poll before you disappear. We'd really appreciate your participation. Thank you so much. See you in a moment. Right, good morning once again. Bjorn, can I check if you're back? Bjorn?
I
All right,
don't think it's yet.
okay, no, that's fine.
Yeah.
Okay, thank you so much for confirming. I think we can continue with the training and we'll probably just have more delegates join us as they go along. Are you okay with that?
I'm good with that, thank you. And all right, so basically I'll just start off with the questions in the chat, if that's okay. It's a very interesting reading during the break. So I'll just start at the top. Okay, basically there was a comment from Jared with regards to the standard technique of replacing individual lights that in terms of maintenance, and taking ultimately, instead of just, if you got a stretch of road and it's all yellow lights and then just putting up a new white light up, ultimately go to a more remote site with a similar aged lighting technology or yellow light, taking them and then moving it over to where you need the lighting, and then start looking at replacing that lighting on the other side, basically where it's less important. And then gradually you ultimately, or in addition, you do roll-up programs where you set aside a budget to basically say, okay, this main road, you're going to upgrade, and then all the existing stock from there you then save and refurbish, and then use again to replace those one or two light fittings in those road sections. Good comment in terms of glare, and thanks for that in terms of the comment about the opportunity of upskilling in terms of measuring glare and calculating glare, so that it can be accounted for in the workplace. And then moving on to that is the estimate. Okay, is there a way to estimate energy savings from using presence controls, as there is no way of predicting when people will be and not be in the room? So okay, so from a measurement point of view, you can just physically put an energy meter on that circuit and measure how often. There are simulation tools available also that can basically look at the traffic of people within a building, how they basically move around within a building, but that's advanced software. So from a basic estimate perspective, there are assumptions that can be made. I'm not going to make them now, not with understanding the circumstances, but just as an example, is a call center, for example, a big open space, all right, and the employer does have a shift register. So this half of the building, employees will basically go to lunch, all right, and then basically come back. So if you have you then have an understanding that for 8 hours of the day people are at their desks. That's just like a general assumption in that general area. For 6 hours of the day, the other 2 hours they are basically taking breaks or are having lunch and so forth. And then altering that's for half of the building, and then the other half basically has a shifted timetable. So there you can actually then estimate the overall saving in terms of lighting control for that area. Then again, in terms of lighting design, if you are looking at use of natural light, in addition to presence controls, lighting simulation tools could basically be used with these controls. All right. Jared, thanks very much. In terms of budget, including rand per lumen, that's definitely applicable to the finances at the end of the day in the client's pocket. So very good points to bring up there. And yes, most LEDs are important or assembled in part locally assembled, manufactured locally. Or actually, there are manufacturing entities, not necessarily in terms of lamps, but as I say, we do have a large market, but again, expensive down the line. So that's true. And unfortunately, also like even getting cheap components like the LED chip boards, drivers. Also, these are components that get manufactured locally that support the lighting industry to manufacture lamps and luminaires locally. Unfortunately, we are in competition with imports in terms of scalability, and that does impact the supply chain basically of luminaires. And then Dr. Tabela, thanks very much on your take on the billboards and the glare from these. And yes, there are standards available, and I've noted that the VCs that are potentially applicable, yes. And Ashanti, see that you've just also been asked to shed some light on that one also, in terms of how NRCS can assist in there. I know from National Roads Authority, even though you have, say, these digital signboards on the properties of landowners that are next to the road reserve, there are notices referring to infringement of the road reserve. And so, and the basis of the infringement revolves around the safety of motorists and pedestrians. So if that infringement onto the road reserve basically relates not specifically to a physical element, because the structure of the billboard is outside of the road reserve, but the effects basically penetrate into that envelope of the road reserve, and they have give a risk element from a visual perspective. So that is a potential infringement that could be communicated through to various road authorities. Okay, sorry. In terms of procurement process, is local content not priority in line with section 10 of the BE charters? Really, that is dependent if we are looking at whether we're doing public procurement, private or private procurement. So there are various procurement strategies that are implemented. I mean, it's from CAPEX to OPEX operations, and then the various services from the homeowner all the way to state entities. So the various procurement strategies, but ultimately we can have a look at that when we touch on that subject later on. Okay, I think I've addressed all the questions. Replacing a high wattage bulb with low wattage one does not save energy. Okay, Andile, so just to touch on your question, so if you have a high wattage light bulb, so say 60 watt incandescent, and you replace it with a low wattage one, how does that not save energy? Well, if you look at a 60 watt incandescent light bulb, that has a power factor of 1, so it's consuming 60 watts. If you have a lower wattage light bulb that basically consumes 30 watts but has a power factor of 0.5, you're pretty much consuming the same, if not more, energy than the 60 watt light fitting with a power factor of 1. So there are no energy savings in that regard. So just watch out for those marketing tricks. Okay, just give me 1 moment. Hope that helps in that. But also, if you are looking in terms of savings, that's also how does the light, because if you're looking at a general service lamp versus a downlighter, if you're going to replace that general service lamp, which has a radial light distribution, with a downlighter, which has more direct light, yes, you are getting energy saving, but now you are compromising your lighting quality, because now you have a spotlight effect rather than a general uniform dispersion of light in the area, which would then meet the OSH requirements. Okay, moving on then, procuring the right light. And this will basically touch base in terms of the procurement process. Sorry, can everyone see my screen?
Yes, clearly. Thanks, Bjorn.
Cool, thank you. Okay, so procurement guidance. So develop procurement strategy guidelines. So the public procurement processes, like they can be adopted and adjusted accordingly in terms of Treasury's guidelines. Develop awareness and capacity building of procurement teams, so that when you are taking the general pro forma bid document, when it comes to the bid evaluation criteria, ensuring that that section of the document explicitly outlines what is going to be evaluated. Because from a legal technical perspective, if you are not clarifying evaluation criteria within the bid pro forma tender section, and later on in the technical specifications, one makes mention if you do not, if your lighting levels do not comply to X, Y, and Z, this will be evaluated on a technical basis. If it wasn't mentioned in the tender evaluation criteria, from a legal standpoint, I speak under correction, you may not then reject that bid because it wasn't a qualifying evaluation element or criteria to basically reject a certain bid submission. I hope that does put some clarity. So in your, okay, let me just simplify it. So tender clarification, or in the so you want to evaluate 1, 2, 3 criteria, and in your further outside, and you've stipulated that in your tender evaluation criteria. Then further down in your document, in the scope of work and so forth, you then make mention, by the way, we are also evaluating number 4 criteria. And if number 4 fails, your bid submission is seen as non-responsive. Unfortunately, because you didn't stipulate it in the initial tender criteria, you can't necessarily use that to declare a bid non-responsive. So hence why I develop awareness and capacity building of procurement teams, so that you understand what you are trying to procure, and that you have all those respective criteria, so that you have your technical team that understands the technology inside out. You have your finance department, you have your procurement department. We all have our respective roles, but we need to work together in order to understand what we are trying to basically procure at the end of the day, so that we all meet a consensus. And hence why basically upliftment programs are of importance. So when you are defining your procurement requirements, from a technical perspective, make use of the latest research and international standards, establish the lighting quality criteria, the energy efficiency criteria, key performance and financial indicators. So the rand per watt, return of investment, the lighting levels, or quality of lighting level that one wants to be, so that to a certain extent, if you're doing sports lighting or textile lighting, you want to be able to say, right, this is the type of lighting I need in order to ensure that, or even in the motoring industry for manufacturer, that the lighting levels need to be at such installed in such a way and of such a quality that we can actually see the quality of paint on the vehicles. And ultimately developing and tailoring these procurement documents to the employee's requirements. So, and that basically addresses the one question in the chat about local content priority, as well as section 10 of the BE charters. May or may not necessarily be implemented in all procurement documentation. Further to that, promote the appointment of sustainable workforce or services and material for sustainable infrastructure. So that comes back to price and preference in terms of public procurement. Don't necessarily just use price as a requirement, because that may basically put the infrastructure at a disadvantage and ultimately resulting in reduced performance of lighting as well as energy efficiency. So instead of going forward, you end up going backwards. And then ensure that, as I've previously mentioned, that your evaluation criteria align with what you are wanting. And then, of course, ensure that the actual bid submissions meet the expectations prior to appointment. Sorry, Shanti, I've just gone into load shedding. Can you just indicate if I'm still auditable?
Yes, I can still hear you from my side. Thank you.
Thank you very much. Okay, so moving on to the importance of maintenance.
I've acknowledged the hands. Sorry, Bjorn, to interrupt you, but I think let's just drive this section. And then when we take a break for Q&A, we'll address all of the questions and comments at once. Thank you.
Cool. Thank you very much. So I'll move in then on to the importance of maintenance then. Okay. So what are we maintaining? Are we maintaining material assets, supply points, cables, light structures, luminaires and lamps? Or are we maintaining our visual purpose and experience, our safety, I'll just basically pause here. If you basically look at the road lighting or the traffic volumes, taking family on a trip, pedestrians, education, and just overall interaction of the human presence, basically. And that's what we are looking at, is to maintain our visual, our safety, our well-being, in addition to our visual purpose and experience. And so lighting infrastructure is only as good as the ability to manage, operate, and maintain it. So some of the risks in lighting maintenance: public injury and fatalities, reduced performance and productivity, employers' reputation, theft, vandalism of infrastructure. I know that's rampant at the moment. Criminal activities in communities, also something that's rather rampant, especially and both of these elements are compounded with load shedding. And just let's consider load shedding on its own, with the lack of maintenance and ailing infrastructure, because load shedding can basically be seen as a priority risk just on lighting maintenance. If you look at our public roads have public lighting to improve the safety of motorists and reduce incidences on the roads. Now, if you have load shedding, suddenly public lighting is no longer present, and in addition to glary signboards, we end up increasing the risk of fatalities or incidents on our public roads. And the same basically goes in our communities, where they may have wanted to basically have community activities out at night, and ultimately commuting from public transport to their homes on foot. All these activities are affected by load shedding, with increased criminal and vandalism of acts on the infrastructure as well as within the communities. And so it's a matter of basically just bringing this all together and seeing how to best mitigate such risks around maintaining the infrastructure. And unfortunately, some of the challenges in reducing these risks is financial, having adequate specifications, procurement processes, engagements with communities and employees and understanding of the needs and requirements, energy efficiency versus good lighting, advancing technologies, and end-of-life safe disposal of assets. So all of these are challenges that face lighting from a maintenance perspective, and how we basically incorporate all of that, along with shortages of skills in training, availability of material, variety of stock. So variety of stock is, for example, a maintenance crew have fluorescent tubes, LED tubes, downlighters, general service lamps, flood lighting, street lighting, and those are just the general types of lighting. And then you've got multiple variants of them. You've got a warm white, cool white, daylight, various optics. So a variety of stock, which makes it difficult for staff to understand or simply maintain current infrastructure. And that kind of leads on to basically poor materials, poor workmanship, reporting and attending to failures, poor programming of turnaround time of rollout of replacement of light fittings, and then of course the lack of accountability and responsibility for failed lighting infrastructure or lighting within a building due to poor maintenance being undertaken, either from the employer's perspective or from the contractors or the service providers or staff not reporting it, seen as, well, I can see what I'm doing, it's of no concern to me, why should I report it? The employer's responsibility in terms of the OSH Act to account for such a risk, the maintenance crew to do a daily or weekly inspection of the area to identify failures and replace them as soon as practically possible. So these are the challenges that we face, and moving from the risks and the challenges, it's important to have a set of guidelines for a office block or for a company or for a state entity that looks at how should they basically maintain their infrastructure. And this is how they it needs to be procured, and this is how we can raise awareness with dealing with the technologies, dealing with the risks that we are facing now. There's no point in having a maintenance schedule that's from the 1800s that says, well, if the candle burns out, go ignite it again. Meanwhile, we are dealing with more energy efficient technologies with abundant theft and vandalism. So it's how do we mitigate the risks and address the challenges and efficiencies with new maintenance strategies through our tasks, daily tasks and operations. And so we develop, revise auditable management, implementation, and operational processes, and while developing a sustainable orientated specifications that are updated based on these assessments, and so that we can provide effective procurement and implementation through our maintenance strategies, so that we can adapt to the challenges of today and constantly measure and verify that what we are implementing is actually working, that we are meeting lighting requirements, that we are providing safe or functional lighting with minimum risk to safety. And then, of course, more importantly, is to always go back, review, revise, adapt, and improve, so we can further better our maintenance of our lighting infrastructure. Like the comment earlier about the materials within the luminaires that may not necessarily be toxic now, but there are other elements that are not favorable to the environment. And so revising the specifications around environmental impact so that in the future we do address those issues. Okay, so that basically takes on our lighting maintenance. Shanti, shall we continue with the applied lighting at work, or to take on these questions before I go into the examples of applied lighting?
Yeah, perhaps we can spare some minutes to go into any burning questions. I'll allow for hands as I don't see any new questions in the chat. All right, I don't see any for the moment, Bjorn. So perhaps
cool.
we continue and then we'll just keep checking if there's any interest around discussion. Thank you.
Okay, thank you very much. So basically, I start off with a poor example of retrofit lighting. So we have fluorescent lamps, recessed light fitting, 3 T58 T858 watt fluorescent lamps, right? And ultimately, so let's see if I can get a pointer going here. No. Pointer options. There we go. Providing a wide light area distribution. All right. So without detailed specifications, and simply just replacing the fluorescents with LED fluorescent replacement tubes. All right, we end up with this sort of light distribution. And so basically you can see there's quite an effect in that it's almost a spotlighting effect. So you're going to have high intensity lighting beneath the light fitting, but nothing beyond the light fitting itself. As I say, this is just an example, but exaggerated just to show why it's important to consider the elements around retrofitting. And so I put retrofitting in inverted commas because you are replacing and you're not really retrofitting. Further to that, as a poor specification for lighting from a state entity, whereby they seek to retrofit lighting in its main office. The project scope assess and convert existing lighting fixtures to be able to fit LED light tubes. So they're basically saying this is the type of existing lighting available to them, and they want to replace a 36 watt with an 18, 58 with a 22, and then a 75 watt with whatever LED equivalent. Okay, and then they provide you the quantities. So first and foremost, what are the tasks being undertaken within the main office building? And this relates back to the OSHA as well as the lighting standards, where we need to understand the lighting criteria so we can establish the quality of lighting that needs to be provided, so that we can then determine the lighting technology and how we can make the lighting system more energy efficient and compliant to regulation, to standards, and meet the energy requirements also. And all of that is pretty much lacking in, and this is the actual scope specification around the lighting. You have the entire procurement document and then half a page that relates to procurement, the specification of the light fitting. All right. So that's why I say there is quite a slow transition, and why awareness is very important within procurement teams, within the technical, so that we ensure that specifications are drafted correctly to address the need for energy efficient lighting, as well as other scenarios like ventilation, refrigeration, and the likes. So it doesn't just apply to lighting, but it can be applied to other services also. All right. So moving on to an example of cost replacement. So this is where I made the comment around, do we look at what would be the best lighting technology to implement? So here we've considered 3 topics. So retrofit with LED tube. So replacing 3 T8 36 watt fluorescents with 3 18 watt tubes. Repeat again, but what's different is that we have a low quality unspecified and a high quality LED tube, and then we look at changing the technology by taking away the existing fluorescent light fitting and replacing it with an LED solid state lighting panel. The difference is that you have your respective failure rates, longevity in terms of operational hours. So the LED panel has 55,000 plus hours. Is it dimmable? So controllability. So the cheaper fitting or lighting tube, not dimmable. more expensive lighting tube is dimmable, and the lighting panel is dimmable. Degree of quality, as mentioned, low, high, high. Daylight harvesting dimming, so because it's not controllable, you can't dim it. So there's no daylight harvesting. So you have natural lighting. So instead of having the lights on at 100%, why not make use of natural lighting in the room? And that's basically where the other two high quality products come into effect. So the cost of purchase of the one tube is about, for the cheap tube is 50 Rand, 350, 1,100. So overall cost 3 times 350, 3 times 150 is 150. Ultimately, you're taking the existing fluorescent fitting and you're needing to rewire it for the LED tubes. So that's a labor cost. And then basically luminaire compliance testing, because you are changing it, and then ultimately you need to just test that it is compliant overall. Whereas the LED panel is already has its test certificate in hand, and it's just a matter of connecting it to the existing system. Then the labor for the installation, and then of course the initial capital cost. You'll see that the LED panel is at 1,200, and then overall the total system power, you end up with 54 watts. The LED panel is at 40 watts. So you are economically cheaper, you're consuming less energy, and therefore overall saving is about 62% versus 50% for my standard 36 watt fluorescent lamp. Okay. Ongoing with energy efficiencies, so looking at from a general perspective, the improved energy efficient lighting strategies and lighting technologies. So this is just to graphically show that if you do look at a light fitting 336 watt T8s, from an energy consumption per annum will be about just nearly 800 Rand per annum. Swapping it out with T5 technology, so this is technology development. So you went with the T8s, you replaced them with the T5s. Your energy, your cost per annum reduced to 600 Rand, and then with the T5s, you reduce them further with 13 watt LED tubes, and that brought the cost down to 280. Then ultimately, let's see how we can actually improve the lighting design or the efficiency of the lighting, and that brings down your providing you with a more efficient lighting design, bringing down your costs further, and then ultimately also looking at, instead of using LED tubes, what happens if we use newer technology, solid state lighting panels, and so as well as lighting control, daylight harvesting, presence sensing, thereby maximizing energy savings to about 80% from the initial technology that was installed of 336 watt T8 fluorescent tubes. So it's basically shows you how advancements in technologies, advancements in best practice design, and applying quality lighting design as well as quality lighting products can lead to improved energy savings. Looking at another example around lighting is school lighting. So you have direct lighting as is typical in a school of today. I remember basically open channel fluorescent lighting in my classroom back in the day, 4,000 or neutral white lighting, big windows, not that they helped with ventilation in the hot summers. All right, lights were on, even though you could see perfectly without the lights, with the large windows. And ultimately, with the light being directed downwards, without glare or any passive protection like blinds and directing the light, if the sun basically comes across the top over here, shines straight in, these poor learners over here are definitely going to have glare as well as be fatigued through the heat exposure through these windows. And so those are elements that one needs to consider when doing lighting control, or even ventilation and temperature, climate, ambient environment control, basically. And this is just from a classroom, because the learners on this side may be distracted by a flickering light over here, or the learners on the far side are basically too tired because they're overheating or not getting enough ventilation, and then ultimately who suffers in terms of learning. All right, so in essence, basically sit near the front and in the middle, basically where the hopefully the average of all of the effects is middled out. But that's standard. So how can we improve it? Well, basically provide glazing on the windows to mitigate glare, as well as thermal penetration into the classroom, so that the classroom is equally distributed in terms of light. You can even put in louvers, so that the natural light is basically reflected from the louvers onto the ceiling, providing indirect light and more uniform light, rather than more direct light from the light fittings. And even here, basically, you're looking at the artificial lighting when natural light is not sufficient, that it's pointed upwards, providing indirect light in the classroom, rather than having direct lighting on the learners below. And ultimately, that's what's beneficial there, is that if there is any flicker or stroboscopic effect, it is slightly reduced through the upward being diffused in the ceiling itself, the effects that is. And using more energy efficient technology, and technology that mitigates flicker and stroboscopic effect and glare. So those are things to consider, because if you are looking at, even if you are sitting at the back here, this light is above the chalkboard, basically. You won't be able to see what the teacher is basically writing on the board, because you are of disability care or discomfort care from the light fitting above the chalkboard. And so this is just looking at in terms of light spectrum or intensity, or light distribution within the classroom. So you can see high intensity on the desks of the children in the front here, as well as at the back. Whereas there's a uniform light distribution, not necessarily the same level as the children over here, but the light is more uniform and less direct, so allowing for more focus of learners in the classroom. Okay, another example from a maintenance perspective, and this is one of the trends, is that you'll find that a client has basically undertaken an energy efficient rollout and said, okay, right, I want all my offices replaced with LED lights. So they go out, they do that. Then the maintenance personnel come in, and a year later, ultimately, you find that there's fluorescent tubes and CFLs being used. Why? Because these were stocked at the time of the replacement, and rather than procuring new energy efficient technologies, they are making use of the stock. And so you find that the whole initiative of energy efficient lighting is lost, because you're making use of the existing stock. And so this example here pretty much goes to show what, like, does one take the existing stock, use it, and get the return on investment, so to speak, of the stock in hand, or should you basically go out and take your stock and dispose of it safely? And here we look at an office floor with 50 light fittings. Each light fitting has T8 58-watt fluorescent tubes, so there's 150 lamps. Okay. In addition to that, you have 150 fluorescent tubes in stock at 60 Rand per lamp. So the cost value of your stock for maintenance is 9,000 Rand. If we look at the, sorry, I just, one moment. sorry, my mouse is just freezing. If we look at a 5-year financial expenditure comparative between making use of the existing stock, so as there are failures, you just replace, but you're consuming energy at 58 watts. All right, or do you basically say, right, let's dispose of the existing stock as well as replace our existing lighting with energy efficient LED tubes. And so what you'll find is, okay, to replace all 50 light fittings with 24 watt T8 LED tubes will cost you 18,000 Rand roughly in terms of procuring the LED tubes. The operational cost basically looks at failures as well as cleaning the luminaires and operation of the luminaires. So with that, you have your fluorescent tubes of basically 13,000 hours versus 50,000 hours, 25,000, 30,000 hours operational life. So lower failure rate compared to the fluorescents, minimal exposure, health exposure risks to the LED possibly in terms of UV for the fluorescents. And then of course, energy consumption. If you're looking at 24 to 58, that's 50% energy saving. So logically, it's basically a 50% energy saving cost in terms of rands. So what does that mean? Overall, you're looking at 320,000 Rand saving over 5 years, or 300 Rand saving per lamp per year. So should you basically keep those 150 lamps, install them when you need to, or should you just basically dispose of them safely and go out and buy LED tubes and do the full replacement? I think this is a good example to basically show the benefit of implementing energy efficient technology, quality energy efficient technology, and quality lighting. All right, on a more grander scale, freeway lighting retrofit to LED luminaires. It's more recent, the Buccleuch interchange. All right, according to the lighting standards, you need to provide an average illuminance of 30 lux within the interchange itself. So with the old yellow light or HPS lighting installations, 600 watt light fittings, we got an average illuminance of 29.8 lux. So within, that's pretty much equal. Implementing more energy efficient LED lighting retrofit, getting 31.2 lux. So you can see that you're almost getting spotlights, and here the distributions are more even in the orange there rather than more red and so forth. So how does this basically look out on site? So well, it's not clear, by the way. Right. So from lighting examples to perception of lighting. I mean, exposure to various communities and so forth, you can understand that there are limitations to access to lighting. I mean, in the absence of lighting, communities are in fear of leaving homes after dark for safety and protection. And you had rioting over here, no lighting being provided. And basically, when there is lighting, communities come out and have that community togetherness and engagement of neighborly communication and so forth. So lighting does create a sense of well-being within communities, and in that also economic power of the community also. And in the absence of it, going back to the Sustainable Development Goals, I mean, the lack of lighting basically does impact on sustainable education. And then with that, so you're looking at various technologies of giving access to lighting, such as solar lighting, lighting of the communities, remote lighting, so that individual homes can basically make use of have light within their homes, as well as portable lighting with the torch, and being able to charge other devices, so as to provide education and entertainment and so forth. And then, of course, another means of lighting is the Liter of Light project. All right. And pretty much this
lugar namin, Sitio Maligaydos, San Vicente, San Pedro, Laguna.
Siyempre, alam mo naman, ganitong lugar, squatter area, tabing release, dikit-dikit ang bahay.
Madilim talaga rin sa lugar.
Wala kami dito sa loob, lagi kami sa labas. Nadadapa kasi madilim, yung dadaan, hindi mo alam, may nakaharang. Tutulog na lang ako, wala ilaw eh.
Ang tawag niya sa dito si Mang Dimi Solar. Napaliwanag ko yung bahay niya naman sila. Pupuntas ka ng yero, lalagay mo yung bote, lagyan mo siya ng silang, bago lagyan mo siya ng tubig na mineral, lalagyan ng syrup. Kapit mo sa bahay, lagyan mo silang to para hindi tumulo. Dahil lang kasimple yun. Dating ganito, pagkadilim ng pagkapitan. Kaya nung kapitan mo na, ito na ang liwanag niya. May naliwanag.
Hindi po ako kasi bote lang, tubig. Maliwanag na yung bahay.
Bumaba yung ano mo, pinayakan mo yun. Wala kang makapitan ako dito. At saka itong solar button bulb na to, hindi mainit.
Dahil sa buti na yan, sa solar na buti na yan, kumanda ang araw namin.
Ang nalagyan na namin ito ay bali 643. Gusto na namin tuloy-tuloy para maraming matulungan. Mga tao rin na yung maliwanag ng mga bahay nila matitilip.
Parang katulad na rin ng bumilya. Dati natin ang kalimutan at pakinakalan ngayon. Maliwanag na sa bahay namin!
So yeah, just a creative way of basically recycling plastic bottles, adding some water and bleach, and then making use of light diffraction within the bottle to basically promote light within the dark dwellings. So that's just another perception of light there. Yep. In addition to that, we need to understand that lighting affects us differently. Visual impairment, autism, sensory processing disorder. I mean, visually impaired persons need more attention to lighting needs to aid them in their vision. And then, of course, understanding how lighting basically impacts all those with sensory processing disorders, and how the lighting can basically be used to improve learning abilities, basically, especially of young kids. And then just going to the polls before moving on to I think it's the last section of labeling. That one.
Thanks, Bjorn. Can I field 3 questions to you while we wait for the response to the poll. Yeah, and then that should lead us into the final section.
Sure, thank you.
Yeah, just the first from Jared said, how does one do a procurement request for a type of luminaire when a quality design is always done with a specific light, and redoing the design when a new light is suggested? Do you understand the question, or should we ask him to clarify?
No, I understand it perfectly, and I see it quite
Okay.
often.
Thank you.
And unfortunately, I don't like it. From a professional perspective, I don't do it. When I do, and that's the emphasis is on good lighting and good energy efficiency. So you don't do a lighting design, let's say for street lighting, to maximize the spacing to say 100 meters. But now that 100-meter spacing can only be fitted with one type of light fitting. So your chances of trying to replace it with more energy efficient technology or something like that is going to be hard felt and hard searched for. So rather basically change that 100-meter spacing to say 80 meters, because now you're still providing good lighting. It's still efficient, you're not maximizing the efficiency, but you are at least allowing efficiency to in the long run, basically when more technologies are developed and can actually meet availability of from other suppliers to provide you with various lighting technologies. So generally, like what I do is I say, okay, well, what sort of light fittings are available for indoor lighting for a downlighter? Okay, I've got it from manufacturer A, B, and C. Who's the most expensive? So that's what I'll be using in my cost estimates. Who's the most restrictive in terms of lighting performance? So that is going to be my minimum requirement. So that is kind of my gauging in terms of specifying in the procurement documents or for qualification. So that at the end of the day, we get a product that kind of fits in that model, not too expensive, and does perform well. Okay, I think that answers that question.
Thank you so much. And the next also from Jared, is there a resource for complying with the lamp or luminaire disposal? It can be a significant cost. Excuse me, can one donate old lights?
Is there a resource for complying with lamp luminaire disposal? So it can be a significant cost. Sorry, just to clarify resource.
Jared, if you can unmute and just give us some clarity around that question. All right, I'm not sure if Jared can hear us, but in the meantime, let me just move to the third question.
I've read it already. So Isaac's asking, was the physical lux measurement using a lux meter that was done before and after the change, just to compare it to the simulation? Yes. Basically, we took multiple lux meters to measure the old installation, and basically on the basis of confirming, verifying, was the proposed design more energy efficient. So yes, that was done.
Thank you so much, Bjorn. I think we're good to move on.
Okay, and I just want to if I'm not answering correctly, Jared, if you could just come back. So in terms of resources for lamp and luminaire disposal, there are entities that are credited for luminaire and lamp disposal recycling waste, and then there is sorry, I forget it. There is a waste management plan that basically deals with luminaires in terms of the environmental department. It's something I barely know who to contact for. Okay, yes. So there are entities that deal with specifically waste disposal and recycling of luminaires and lamps. And then from a regulatory perspective, Department of Environmental, Forestry and Fisheries, that manufacturers have a obligation for waste management plan in place, and then of course can you donate old lights? It kind of like works in terms of like municipalities for street lighting. You can basically keep the fittings to basically use on other older installations where you haven't implemented, so you at least managing your budgets for maintenance. But donating old lights, I don't particularly like it. Sorry, that's just from our point there, but okay, cool, thank you. Moving on then. All right, a lot of you do find it easy to understand lighting labels. Cool. And then at least some of you just pick without reading the label. That's cool. In terms of labeling, the one day I went to basically replace a light fitting in my kitchen. I ended up spending an hour in the lighting aisle trying to find a specific light fitting or for LED tube, trying to compare which is the best and all of that. So eventually I got what I wanted, but the staff there weren't helpful because they didn't understand the technical requirements I was looking for, and the labeling also varied between manufacturers. So that's pretty much what I'm looking at in terms of labeling in the market. I mean, here's one type of packaging which makes use of the European energy label, indicates that it is warm white, how to handle it, wrong way of handling it, and 20,000 hours, warm white, 6 watts, 750 lumens. And then pretty much, if you look at that, high efficiency LED filament chip up to 120 lumens per watt. But if you take the 6 watts or the 750 max lumens divided by 6 watts, you actually get an efficacy of 125 watts. So that's just a quick calculation. Now my question is, which one's right, or is the whole packaging incorrect? Okay. And yeah, so as I say, 125 lumens, even though the packaging is saying 120 lumens. Then here's some packaging from another manufacturer or sales manufacturer. A lot more detail now. Ultimately, they've got the the SANEDI energy label as what's on the website. They've indicated that it's a cool white. My preference is 4,000 Kelvin as neutral white, not cool white. And then ultimately 480 and 60 6 watt, which is equivalent to a 60 watt. 60 watt incandescent is around about 800 lumens, just out of interest. And then of course the point that I was making about power factor 0.5, so you're actually consuming 12 VA, even though you're consuming 6 watts. And then of course the beam angle and the color rendering. So good quality light color rendering. And then of course it's also not dimmable, and the efficacy is 80 lumens per watt. Then we got to look at different packaging. Here you've got a multi-pack, basically says that it's an E27 type connector, B22, warm white, 5 watts at 360 lumens, equivalent to a 40 watt. Apparently 88% energy saving, 7 watts, 6,500, it's a daylight, 25,000 hours. And then of course you're looking at efficacy of 72 lumens per watt versus 95 lumens per watt. But now, which should you purchase? Well, now you're gonna be looking at cost and then pretty much your lighting preference, assuming that and of course whether you've got an E27 connector at home or bayonet connector at home. All right, and whether or not you prefer daylight in your home or a warm white, which is more relaxing versus blue tinge. Sorry, just give me 1 moment. I just want to There we go. Sorry, I just had some markings on. Let's just get rid of. Okay, so what labeling should be expected? So under the new VC, and what should be considered as a minimum across all lighting technology, where some sections are mandatory under the VC for general service lamps. You should basically know what the rated power is, the rated voltage, brand name, luminous flux, how much light output, the color temperature, and the beam angle. So that should be information on the lamp itself or on the light fitting itself. Then the packaging information, so what's the box, the packaging that the light fitting comes into, looking at, again, the watts, the voltage, the lumens, the efficacy, the lifetime in hours based on an L70B50 failure rate, the base type connector, like the E27 and B22, the rated color temperature, whether or not it can be dimmed or controlled, and then, of course, the efficiency label compliance in terms of the Department of Energy guideline. So there we look at, and Ashanti, you're more than welcome to come in here, but I'll just quickly give a quick brief of this, and then you can provide the update to it. So that is generally what should show up on the packaging, where you're looking at how efficient from a graphical perspective the lamp or lighting technology would be, the light output in terms of lumens, the input power or consumption of it, and then, of course, the rated life, longevity of the product. Any further comments from your side, Ashanti?
Thanks, Bjorn. Yes, so just a quick one around the energy label review project that we are currently undertaking. We conducted a market assessment around the reception of the energy efficiency label across all appliances, including lighting, and consumers have given views that assisted us in developing a project to actually revise the current label as it stands. So what is reflected on the screen on this slide is the standard lighting or lamps energy efficiency label. But of course, the label is adjusted in terms of the information that appears depending on the electrical appliance that is being referred to on the actual label. Currently, the labels are not standardized. You will see some are an A++ to D and some are A to G, as with the one that's reflected on the screen. So that's the other feedback that we received from consumers, that they relate better in terms of understanding to the A to G model. So we are revising that part of the label. And then also some of the information that does appear on the label is considered very technical for everyday consumers that are not experts in the lighting industry, so to speak. So we've been advised to rather use infographics with a minimal explanation of various factors of the actual lamp or product itself, and then supply a QR code, which is going to enable further technical detail information, perhaps in different languages, warranty brochures, etc., that can be populated onto that QR code. This will also be accompanied by an app which will assist consumers to use the data provided on the energy efficiency label in order to calculate the annual consumption of the product that they consider buying, or perhaps the lifetime consumption if you multiply it by the number of years that you do plan on keeping the appliance. So these are all factors that we have to incorporate. The energy efficiency labeling program is one that's consumer intensive. It does rely on consumer behavior science as well as consumer feedback, and ideally, every 5 years, we should be upgrading the energy efficiency index for each product, but also to receive feedback from consumers to understand if the label is effective, and then to make those adjustments accordingly. So we are in that process at the moment. I think a question came up in the chat as well around the energy efficiency label for lamps with regards to the new general service lamp regulations. that will be enforced from May of 2024. As I said, that the label is being upgraded for all appliances across the board. The lights are just one product in a list of other products that we also have to update the label for. So we are doing our best to ensure that the updated and new label is going to be issued out. It is a consultative process, so industry will also be engaged with regards to their respective products. The lighting industry, lighting manufacturers, and all the industry members that we work with in the space will also be consulted regarding the draft of the new face of the label. We need to consider that input, table it forward before the DMRE approves the new South African label. I also saw somebody was saying that there isn't a standardization around the local labels. It's, you know, there are incompliances in the space as with every regulated space, and it's very important that you turn to our guideline for minimum energy performance standards and energy efficiency labeling, which is available on www.savingenergy.org.za, because that will actually show you the differences in the labels that are out there, those that are legal. An example of the correct label is what you see on your screen, but you also have some counterfeits that will be printed and put on products that are not complying, and there will be evidence of that. So we do have a few examples of the fake labels on there as well, so you can tell the differences. But key things, it must have the energy efficiency logo of South Africa, which you see on your the top left. It must stipulate all the relevant information and have the scale as you see presented there for lamps. Thanks, Bjorn.
Thank you, Shanti. And then just to quickly go back to that one example. So there's an example of the label in practice, and then that is not a valid label, basically.
Yeah, this is the EU label. So this is also a huge issue. If you have products on the shelf that are displaying an EU label, this is the kind of incompliance that you have to report, because they have then shipped the products in labeled directly from the country of origin without getting the corresponding South African energy efficiency label, which complies with the letter of authority application process that you mentioned earlier. Thanks, Bjorn.
Well, thank you, Shanti. All right, then, yeah, that pretty much brings us to the end of it. Hopefully we've assisted you in how to read the labels and what to look out for. And yeah, thanks very much. If you won't mind just basically completing the last poll, that's out. If you won't mind, where is that? Sorry, I'm just trying to figure out, where is it now? Ah.
Is this a poll question, Bjorn?
Yes, sorry, it is a poll question, so I think I've just launched it.
Thank you. I just want us to also cover some admin while we are getting some responses from the participants on that poll question. I do see that there are a couple of comments in the chat. Much appreciated to all of you who've shared some contributions. There are a lot of input and suggestions that we're going to take forward as well. I don't note any questions from the last round that we conducted. I would like to give an opportunity to Motlatjo just to quickly run through a few admin points that our participants need to take note of before we close off our session. Over to you, Motlatjo. Motlatjo, are you there? I've noted your hand, Henk. I'll come back to you.
Oh yes, I'm here. Sorry about that. I had some technical problems with opening my screen. Okay, in terms of the announcement, I have few announcements to make. The first announcement is the attendance certificate. Our attendance certificate, it will be having the CPD points. However, at this moment, we are still under evaluation. There are people from EXA who are still evaluating the training. So once they confirmed with us how many points are we getting, then we can be in a position to issue those attendance certificates. And also be aware that only those who have attended at least 80% of the session will be eligible for the certificate. And then another announcement that I want to make is that the presentations will be found under the website www.energysaving.org.za, which is the SANEDI website. That is under the events tab, as I said in the chat. And also there is an evaluation and feedback link that we all need, that we are requested to fill so that so that we may know your feedback and everything. And then for the AEE credits, we will confirm with you. Then we will also be requesting them. That is my answer to Jared. And also next week we have the last webinar of the year, which is about sustainable and cost-effective of life management of solar PV equipment in South Africa. And that will be the e-waste disposal and recycling of your solar panels and of your solar equipment. So if you, it's also free to all the SAC members, and you are all more than welcome to register and join us. It will be on the 7th. I'm just pasting the registration link here in the chat, and I'm not sure if there's any other announcement that which I'm missing. Oh, and also the presentation will be under the SAEC website also. And it will be under the membership portal, along with the recording. So thank you very much.
Thank you so much for that, Mutlacho. I've also just posted a link where the presentation has already been loaded on the Saving Energy site, so you can just click on that to access it immediately. And once we have the recording for the session, we'll also add it to the same link. Henk, I'll give you a minute to take the floor before we close the session. Thank you.
Yeah, thank you, Ashanti. A minute is very short. Yeah, I'm Henk. I'm representing AISA, the Lighting Association. I think energy efficiency is extremely important topic. And I feel there are a lot of initiatives, especially since this year with all the load shedding. And I feel there's a huge need for events like this. If I look at the questions, the interaction, you see some remarks. And I feel that maybe we should join hands a bit more. Please involve the industry in events like this. I hardly saw people from the industry amongst the participants, probably because everybody's very busy closing the year. But yeah, on behalf of the Lighting Association, we are always willing to help and support any energy efficient lighting events and initiatives. I also feel that although we are almost 3 hours now, we've only scratched the surface. One topic that I absolutely missed was the whole financial part. I saw Björn had budget as an important topic and some examples. But I feel financing is crucial, yeah, because this is always used as the major roadblock, and we have to be simply more creative. Yeah, I think it was 5 weeks ago, 6 weeks ago, there was an event in Pretoria, energy efficiency in buildings. I think you are not there, Ashanti, but many of your colleagues. And there was a lady from Nedbank about finance, green finance. And one of the topics she absolutely missed and even wasn't aware of is the as a service model. Yeah, because if you go for as a service model, you don't have to pay upfront, but it's a monthly or quarterly fee, so budget is less relevant. So I think in events like this, we should include that. And then, yeah, I actually wanted to elaborate on what Björn said, the marketing trick of power factor, but I think my minute is finished. But yeah, I have a completely different view here. But in view of time, I will leave it like that. But yeah, thanks a lot. And again, please let's join hands. This is so important, energy efficiency. So thanks for these 3 hours. And thanks, Björn, for the presentation.
Thank you so much, Henk. I couldn't agree with you more in terms of the fact that we've just scratched the surface. And I think more than anything, that was the main purpose of what it is we're trying to do here. Feedback is very key. I have mentioned that we've noted all the feedback and very valuable insights that have come in through the chat section. And I take you up on your interest to collaborate, particularly around various topics within the energy efficiency lighting space that we need to explore further. In defense of this particular training, it's probably just useful to mention that we went with a broader view to enlighten the public of various aspects of energy efficiency training. And I think, Bjorn, you've really done a fantastic job at ensuring that we cover that scope. But I'm very open to the conversation of seeing how we can go into various niches to try and create more awareness and educational opportunities from different aspects of the sector. So thank you all so much. Bjorn, I want to also just extend a special thanks to you for your time and for this training content that you've collaborated with us on the delivery of the presentation so excellently and timely, and also just engaging all our participants as well as you have. We value your knowledge and experience. So much thanks to you. I'd also like to thank the team at the SAEEC who have been working timelessly to put together this webinar platform. Thank you to my team at SANEDI, who also works very hard to ensure that we are able to give out all of the content that comes in as a request from the public. So thank you once again to everyone. Also extending my final thanks to you as participants. Your contributions have really been invaluable. Thank you for sticking it out, for those of you who stayed with us right till the last hour. And I hope that you have enjoyed this and that it has been enlightening. I'll also just pop my email address in the chat for those of you who have any feedback, any particular questions that you'd like to ask. I'm happy to respond to those directly or to field you to the relevant stakeholders who can assist you further. Thank you once again, and the training has been adjourned.
Thank you very much, Ashanti.
Thank you.
Thanks.
Thank you very much. It was insightful.